Alright, it's Mr. Canada here today. We're going to talk about inequalities and what happens when we have indices on our variables. So, same thing as always, our goal is to isolate x on its own side. So, isolate to find x to the m on a side. Then at this point, we must then use some law of indices to get down. So, for the most part, these are just going to use laws of indices to try and simplify, because that's just the basics. So, how do we do this? Well, this is like saying we have x times by x is greater than 100, right? So, one way to say this, well, if that's x times x is greater than 100, we need to find what two numbers multiplied to find 100 are. Well, that's 10 times 10, right? So we could say that this x is 10 and this x is 10. Right? Because it's just like saying a substitution. If we put in 10 where our x's go, we could have something that relates, right? Anyways, kind of ignoring why that comes about, wouldn't it be great if we actually could do something else and we didn't actually have to think about that? Well, there is. There's, on our calculators, you have the square root function. So, square root of 100 is equal to 10. And that's because the square root of 10 squared is 10. Well, why does that cancel out our indice of 2 when it's a square root? The reason why is we have 10 squared, and really a square root is just the power is 1/2. And then a cubic would be 1/3, and so on, right? So, that is why they actually cancel out, because of laws of indices, because we know that would just be 2 over 2 for our exponent when we multiply. So we're just going to use this idea of square rooting. So if you know what they are normally, it will really help. If not, use your calculator until you get used to trying to think, well, what's 1 times 1? That's 1. 2 times 2 is 4. 3 times 3 is 9, and so on. So here, we're just going to take the square root. When we actually solve this over here. Here, as long as we had our number to one side, we would treat this like normal and do the same operation to both sides. So we want we want x by itself, so we have to take the square root of x squared, and then so therefore we have to take the square root of 100, which is 10. Similarly, we have the square root of x is 6. Well, we have the square root of x is less than or equal to 6. So how do we get x? Well, the opposite to square root is squaring. So we're just going to square both sides. That means on the left, we're left with x is less than or equal to, well, let's 6 squared. 6 squared, remember, means 6 times 6. So 6 squared is 36. So you can see that one way of going about this, if we know all of our squared and cubic numbers, or the kind of the first bunch of them up to 10, can be very helpful, because then it makes our maths really easy. We can almost start to think. And a lot of these numbers you've multiplied since you were in primary school, doing your times tables, 1 times 1, 2 times 2, but we just had a whole bunch of other numbers at the same time. We're just looking for that special diagonal roll on our multiplication tables. So let's look at something a little bit more challenging, because you will get some more challenging stuff. So ignore example 4 for now, because that's the hardest that I'm going to get to. So example 3, what happens when you have varying powers of x on both sides? Well, let's break up our powers then. So look at the highest power and see if you can't write it in with some of the other ones. So what I mean, notice how we have this x cubed term over here. I want to rewrite my left term, this x to the power of 5, as x cubed times by x squared. You might be thinking, why are you doing that, you crazy Canadian? But this is why. So notice there's an x cubed here on the left and an x cubed here on the right. Well, if there's 1 on each side and we want to get rid of one of them, we'd divide by x cubed. So we'd have to divide by x cubed to get rid of that one. Which means we divide by x cubed over here, which means they both end up just disappearing. So what are we actually left with then? We're left with x squared is less than 4. And the opposite to squaring is square rooting. So we have to square root 4, which gives us an answer of x is less than 2. Okay. And lastly, kind of the hardest thing I want to get to with inequalities for the time being is something that this is bringing together everything we've done until now. I decided to leave out any kind of division or fractional just because it can get way too complicated. So if you'd like to give it a go, pause the video now. Always try examples before I get to them. That way you can kind of see where you have your understanding and where you're making your faults. So here, first thing I'm going to do is expand brackets, right? No, what do I keep saying? Tricks, tricks, tricks. So, what do I see on both sides? I see an x term on both sides. So I'm going to get rid of my x term on both sides. Right? Well, okay, let's expand our bracket now. Okay, let's get to... Oh, no, no, no. Look out for those tricks. So, we have 2 on the left, 42 on the right. So I'm going to divide by 2 and divide by 2. Okay? On the left then, I know I can just cross out everything in front of the bracket. And so, really quickly, I have 2x squared plus 3 is greater than or equal to 21. Okay? So, let's subtract 3 from both sides. That's going to leave us with 2x to the power of 2 is greater than or equal to 18. We want to get this x squared term by itself. So divide by 2, divide by 2. We are going to have x squared then is greater than or equal to 9. And lastly, the opposite to squaring something is square rooting. So we're going to find that x has to be greater than or equal to 3. So since we've done such a complicated example, I do want to point out one thing. Notice, if I write out this, right, bid mass. So what did we actually have to do? Well, we ended up doing after we got rid of our brackets, okay? Then once you get rid of your brackets, you always restart bid mass, right? So then we started at subtraction. We did some subtraction first. Then we didn't have any addition. So we did addition, subtraction first. Then multiplication, division second. Then we did indices third. So I've mentioned this before, but remember, when you solve, you're going to typically do bid mass in reverse. So starting at S, ending up sometimes at B. So here are 5 questions for you to give a shot. Please pause the video, and then once you're ready, press play, and we'll go over the answers together. Hey, so welcome back. Let's quickly go through these answers. So here we just have x squared on the left and 16 on the right. So we can just square root both sides, and we'll be left with x is less than 4, because 4 times 4 is 16. Now, we have something, well, that we want to simplify first, right? So we have an x on both sides. So I'm going to cross out my x on the right, cross out this 3, and change it to a 2. Then, what else can I do? Well, I can divide by 3 here and divide by 3 here. So we're going to be left with x squared is greater than, well, 81 divided by 3, don't forget, is 27. Right? Because 7 times 3 is 21. 2 times 3 is 60. get 27. And then here we want to take the square root of both sides. And we're actually not going to be left off with something too nice. We're just going to be left with x is greater than square root of 27. So if it actually asks you for a decimal answer, you'd be able to use a calculator. But we could always approximate it. We could say, just bringing in some approximations, we could say approximately greater than or equal to, and we wouldn't actually use that kind of operation, but you get the idea. You could say it's around roughly 5.2, right? Because we know it's square root of 25 is 5, and then we're just kind of guessing what the square root of 2. Moving on, what do we have to do here? Well, very first step we're going to have to do is square both sides, right? So we have to get rid of our brackets per se. So here we are going to be left with x plus 4 is less than 81. Then we have subtract 4 and subtract 4, and we have x is less than 77. Now we have this guy, so keep in mind we have to square, sorry, I'll do that in red. We want to square both sides to begin, right? Keep in mind though, we have to put this one in brackets. So I'm going to rewrite this over here as x is less than or equal to x minus 2 and x minus 2. Because remember, squaring something just means we're going to repeat what's under it. So we have to, this is going to require a little bit more effort. X is less than or equal to x squared, and then that's minus 4x and plus 4. Okay? So how can we simplify this? Well, let's move that x over and leave it as 0 is less than or equal to x squared minus 5x plus 4. Okay, so that's a little bit weird of an answer because it's left in form of a quadratic, but sometimes you're going to see answers pop up like that. Typically, for normal kind of GCSE maths or just pure maths, most times you won't see an answer like that. We'll be able to take it a little bit further, but for now, you don't need to know anything more. So leave your answer in terms of that quadratic. It's just the biggest part I wanted to bring a point to with question 4. It's just the fact that when we square something, like an entire term when it's not in brackets, make sure you put your brackets on so you square the entire amount. Okay. So bottom one, x squared minus 4 and x plus 2. Well, sometimes with your quadratics, you might think, well, okay, I'm gonna get the same situation as the last, but notice that we've seen stuff in the form of that before, right? That's that difference of two squares. So I'm gonna write that as x minus 2 x plus 2, and that's gonna be less than x plus 2. Yeah? Notice we have an x plus 2 on either side. Let's get rid of it. And so I want to kind of ask a question, even though I know you can't answer me. I want to know because I imagine some people wouldn't have gotten this. What do you think? Do you think the answer is x minus 2 is less than 0? Or is it x minus 2 is less than 1? So take a think about that. A couple seconds, I'll give the answer. So even though it looks like we have nothing left on the right side here, it actually is x minus 2 is less than 1, because if we're dividing by x plus 2, right, something over itself is simply 1, it's not nothing. So we have x minus 2 is less than 1. So here then we can do x is less than 3. Okay, so finish it off.